Hi there! In today's video, I'm going to show you how you can deploy a Flask web application on AWS in an EC2 instance. And as an example, I'm going to use my calorie counter application that I created in a previous video. So basically, this is a ChatGPT powered calorie counter where you can upload an image and it will send that to ChatGPT to be analyzed, and then it will tell you how many calories is in the meal in the image. So I can show you a quick example. So if I take one of my test images from here, for example this one, it will upload it to the server and it will send it to ChatGPT, and then it will respond that this meal has 1050 calories. And the image that I used was this one. So you can decide for yourself if that is accurate or not. Anyway, in today's video, I'm going to deploy this on AWS in an actual domain, because right now it is just running locally on my machine. So let's hop on to AWS and let's sign in to the console. And the first thing we need is a domain. So let's go to Route 53 and register domains. Now I have in fact registered a domain already, which is howmanycalorieisthis.com. But if you want to register a domain, you can do it here in register domains. But we will skip that part because I have done it already. Next, we have to create an EC2 instance. So let's go to the EC2 section and just click on Launch Instance. And let's give this instance a name. I will call this Calorie Counter. And let's pick Ubuntu as the distribution. And we are going to also select the Nano, which is the smallest and cheapest. And let's create a key pair. So the key pair is what we're going to use to log in with SSH to the server. So let's create a new one, and I will call this Calorie App. And RSA is fine and PEM is fine, so let's create the key pair. And it will actually download the private key and it will save the public key on the server. And in the network settings, let's allow SSH traffic from anywhere for now. Of course, you should really pick from my IP. Let's do just my IP. And let's allow HTTPS from the internet and HTTP from the internet. And we're gonna just have 8 gigs of space. That should be enough for this example. But if you're setting up your own server, maybe you want to have some more space. And I'll click on Advanced as well. And I will click on the volume and I will make it encrypted, because why not? And finally, we can launch the instance. So let's launch it. And it has been launched. So let's open it up. And here we have it. So let's SSH into this server. But before we do that, let's create an elastic IP for this, because this IP will change if we reboot the system, or at least if we shut it down and then start it up again. And that's going to be a problem if we want to point our domain into this, because we have to point it by the IP. So let's create an elastic IP. Let's click on Allocate Elastic IP, and we can just allocate it here. And let me give it a name. This is Calorie Counter EIP. And then let's actually associate this IP with that instance. So I right click and I click Associate Elastic IP. And we pick the instance from here, Calorie Counter. And I'm going to click here, allow this elastic IP to be reassociated, because it will make it easier later to reassociate it if we want. Now, you might not want that, because maybe it will be easier to, by accident, reassociate it. So use your own discretion here, what you're going to do. But I will associate this. So now our instance should have this IP. So let's point our domain to this IP. Let's go back to Route 53 and let's go to hosted zones and let's select how many calories is this. And let's add a couple of records here. So currently we have just NS and SOA, but we need to have an A record at least. So I will use the simple routing and I will define a simple record, and it's going to be an A record and it's going to point to the IP, which is this. So let's define that. And because this is only for the main domain without the .beginning, then let's add the .as well. here. And this one is going to be a C name. It might as well be an A, but this is normally how it is done. So we are going to make this a C name, which points to the main domain. So this way, if the IP changes at some point, we can just change one place. We don't have to change two records. So let's create those records and let's SSH into the server. So before we do that, we have to set up the private key, which we downloaded already. So I am going to move from my downloads folder the calorieapp.pem into .ssh certs, which is a folder I have created for all my private keys. And we also have to chmod this 600 or even 400 is probably fine. So only the owner of this file should be able to read it. So let's do that for .ssh certs calorie app. And then we can modify .ssh/config. And what this file does is it defines different private keys for different hosts. So let's add our host here. It is going to be how many calories is this.com. And the identity file is the private key file. So I will change here calorie app.pem. And the user is Ubuntu because that is the default user on AWS in the Ubuntu distribution. But basically now we should be able to SSH directly into this server. So let's do SSH how many calories is this.com. And since we added this to the SSH config, then it will actually autocomplete it for us. So let's go there. And on the first time we connect, we have to accept this certificate. And now we are in like Flynn. So we are now in the server. Let's move our application code into the server. I will first create a directory where I will put that stuff. So I am going to put it in /srv/calorie app. And I probably have to use sudo to do this. But then I also want to chown Ubuntu srv calorie app like this, so that I actually have access to it. Now you can really put the code almost anywhere you want, but I like to put it in this directory. Let me know in the comments where you like to put your application code on the server. Anyway, let's open another terminal here. And we have a bunch of files here which we have to move. I am going to use rsync to move this. So I will rsync /calorie app, so the whole directory we are in, and I will put it into how many calories is that, or is this.com /srv/calorie app. And I'm going to exclude the venv folder, so the virtual environment, because I don't want to put that in there. And I will exclude the PyCache folder. And I might as well exclude the test images folder. And I actually will add some flags. I will add AVZ here. So that should move everything there. So now if we go back to the server and we cd into srv calorie app and we list everything, everything is here. So now we have to install the virtual environment and all the dependencies. So let's do Python 3 mvenv. We should have Python 3 already because it's Linux, but we have to in fact install this, and we also need Python 3 pip. And of course we have to use sudo for this. And since this is a fresh installation of a server, we have to do sudo apt update before we can install anything. Okay, let's try to install these things again. Okay, that is done. So now what we want to do is we want to actually install the virtual environment. So Python 3 mvenv, and then we want to activate the virtual environment. So let's do source venv bin activate. And then we can just do pip install r requirements.txt. And it will install all of the requirements for this application. Okay, so now we should be able to run this application. If you just run python 3 server.py. Then it runs. But of course, we have lots of issues here. First of all, it is only running at port 5000 and only locally. And we are using a development server, not a production server. So let's tackle some of these issues. Now, we could go and just nano this server.py, and we can in fact go here to app.run, and we can say port is 80 and host is 0000. And we can save it, and then if we run this now, we will get a permission denied error because port 80 is only available to root. So we could technically run sudo python 3 server.py. Don't do this, but you could technically do it. Although now we get an error, no module named Flask. And the reason is that when we run sudo, we are no longer inside of this virtual environment. But we can fix this by not running just Python 3, we can run from venv bin python 3 and then server.py. So if we run this, then it actually happily serves this from port 80. So if we now go to our domain, so if we go to how many calories is this.com, then look at this. We have deployed our application. Well, kind of. We still have a few issues. First of all, we are still using this development server, and we shouldn't really be running this thing as root. Also, if we want to have multiple domains and multiple websites on the same server, we can't really do this. We can't just allocate port 80 for this server. So let's tackle these one by one. First of all, the development server. Let's install a production-ready server. And one server we can use is Gunicorn. So let's install that. And how we install that is we just do pip install Gunicorn. Now, you could also do apt install Gunicorn to install it globally, but there's an issue with the virtual environment then. Because ultimately, we are not going to run or start this server from the terminal manually. It will be in a background service. So we can't really easily go into the virtual environment. But what we can do is we can actually now deactivate the virtual environment. We're not there anymore. But what we can do is we can run from venv bin Gunicorn. We have an executable here. So we can run it from there. And what this wants is the name of the main file. So in this case, it is server, but without the extension. So my file is server.py. So we put server here, and the Flask application is called app in here. So then we put a colon and app. And this will in fact already work. There's some more flags we're going to put in this, but if we run this, then it actually runs it. And this is a production ready system. But as you might notice here, we are now running on port 8000 and it's still running locally. So Gunicorn doesn't care about what you have in your Flask application as the port. It uses its own. But still, we can change it. So technically, we could go and say B for bind, and we can say 0, 0, 0, 0, and 80. And if we run this, then again we get these errors because we are not root. But again, we could technically run this as sudo. Don't do it, but I'll just show you. We can do this, and now it is listening on port 80. And again, if we go to our website and we refresh, it's still there. It's working. So now we have a production-ready server, but we still have some issues. We are still using up this port 80 for just this website, and we have to keep this open here for the website to work. So if we close the SSH connection or if we close this, then the website doesn't work anymore. Now, what we could do is we could run this command and put an ampersand in the end, and then it's going to be running in the background. So even if we close this, it stays running. But I don't really trust that it's going to keep running in the background. And what happens if we reboot the server or it crashes. Then we have to go back and manually start it up. So if I now go here and I refresh, it still works. But like I said, if we reboot, it doesn't work anymore. So we have to create a background service. Let's do that. First, I will sudo kill all Gunicorn. Okay, so now we have shut it down. And let's create that background service. So how we can create that is we can nano, actually sudo nano, etc systemd system, and then we have to create here a file. So let's create a file called calorie app.service. So if we create this file, and here we have to put some directives, which I don't remember quite how this worked. I think we had like an init or something, and then we have to have a service, and we have to have an install. Something like this, but I don't remember. So I am going to use my good friend ChatGPT. Create an example of a service file for Linux. And here we have an example. So, okay, I almost remembered it. So let's copy this stuff and let's remove this stuff. So here's what we need. We need this unit section in which we define the description of our service. Let's call this calorie app server. And we specify this after directive here. And this is network.target, which I guess means that this service will start after we have a network connection already started. And then in the service section, we have a type symbol. I don't think we even need the type. And we have this exec start. So this is the command that we are going to run in this background service. So we will replace this with our Gunicorn command. And we have to use absolute paths here. So let's do srv / calorie app / venv / bin / Gunicorn. And we will use server and app. And I will also add here workers. This is something that I didn't add previously. So I will add 4 worker processes. So this is basically to make it more robust with concurrent connections. And we're going to bind. And again, we're going to bind for now at 000080. Now we're going to change this. This is not how you're supposed to do it. Because now we have to set the user to root and the group to root. Because otherwise we can't use port 80. But bear with me. And finally we have to have this install section, which again is related to the sequence in which these services are started up. But we will just leave it like this. And one more thing we have to do is we have to set the working directory. So the working directory is going to be the srv calorie app directory. So let's save this. And after we add a new service to this system folder or edit a service, we have to run sudo systemctl daemon reload. And since we added a new one, we have to do sudo systemctl enable calorie app. And finally, we can start it. So now we can start it just like any other service on Linux. So we can do sudo service calorie app start. And it will start it. And we can also check the status. So if we do sudo service calorie app status, it will show that it is in fact running. So now it is running in the background. And if we go here to our calorie counter app, it still works. And now it's running in the background. And even if it crashes, it will restart. Because, let me double check that we had the restart section. Yes, we have restart on failure. We might put always here, but I guess it will fail with an exit code if it fails. Anyway, now it's running in the background and it will automatically start up if we reboot the system. So we are very close now, but we still have the issue that how can we run multiple different applications on the same server? And how do we get an SSL certificate for this? Well, for that, we need to install Apache or Nginx. But I'm more familiar with Apache, so I will install that. And Apache, of course, is a web server. So let's do sudo apt install Apache 2. And we have to actually stop our service now because it is using port 80, but Apache will use port 80. So let's say sudo service calorie app stop. And let's do sudo service Apache 2 start. So now if we go to our domain, we actually have the Apache 2 default page. So let's go and change the configuration a bit. Let's sudo nano etc Apache 2 sites available. And let's actually cd into this first. So let's cd in here. And I want to sudo rm the default SSL. We don't need it right now. And I will move the 000 default into how many calories is this .com.conf. And of course I need sudo to do this. So now we have just this one in here, and if we want to add more domains, then we can name them in the same manner. But let's edit this configuration. And basically I will remove everything from here. We don't need server admin, document root, or these error logs or anything like this. What we need is a server name, which will be our domain. So this will be how many calories is this.com. And we are going to have also a server alias, which will be just the how many calories is this.com. And then what we want to do is we want to use proxy pass. And what this will do is it will direct all the traffic from port 80 into the following local address. So from slash, we are going to proxy pass into http://127.0.0.1 and port 8000. And this is the port that the Gunicorn will be running soon. And it is very important to put a slash in the end. And we also need to add a proxy pass reverse, which takes the same arguments. And basically, I believe this was so that the actual application will get this domain as kind of the host of the request. Otherwise, it will get this. Or maybe it was the other way. Maybe if you don't have this, then the request back from the server will come as if it comes from this URL. I think that was the point. Anyway, you have to add these two things here. And let's save that. And in order for us to be able to use the proxy pass, we have to do sudo a2nmod proxy. So we have to enable the proxy module and proxy HTTP module. And then we want to also do sudo a2 this site. We need to disable the original default configuration. And we want to do sudo a2 nsite. And we want to use our how many calories is this.com. So now everything from port 80 is going to be directed into port 8000 locally. So what we have to do is we have to modify our service now, our calorie counter app service. So let's do sudo nano etc systemd system calorie app.service. And now we can change this to 8000. And it doesn't have to be public to the world, only local. So we do 127.0.0.1. And now what we can actually do is we can set the user to Ubuntu, not root. So a little bit better, but still it's not good to use Ubuntu because it still has sudo permission. But we will get to that. And let's add the group Ubuntu. And then we have to do sudo systemctl daemon reload. And sudo service calorie app start. So now, if we reload Apache as well, and let's do this with sudo, then we should actually be able to go here and refresh and look at this. We have our calorie counter app running through Apache into Gunicorn. And it's running in the background, and if we restart the server, everything still works. So what's left? We need an SSL certificate, and then we need to figure out what user this service actually should be running as. Because the Ubuntu user still has sudo permission. As you can see, I can just run sudo without any password. So if the server is running as this user, then if we have some security vulnerability in there, then the hacker can run as Ubuntu and maybe they can run sudo as well. So let's fix that also. But first, let's add an SSL certificate. So we are going to use Let's Encrypt. So we will install certbot, and that is done by sudo snap install classic certbot. And what we're supposed to do is we are supposed to actually sudo lns, so make a symbolic link from snap and bin and certbot into user bin certbot, so that we can use a certbot directly from the command line. So then we can run certbot Apache. And do we need sudo? Not quite sure. Let's see. Oh, we do, of course, need sudo certbot Apache. And we have to enter our email address. And we need to accept the terms of service. And we have to decide whether we want some spam or not. And then it will automatically detect that we have these two domains configured in Apache. So let's use number 1 and number 2 and create a certificate for both of them. And that is basically it. It will automatically get the certificate, and then we should have an SSL certificate and it should work right away. So now, if we refresh our how many calories is this.com, it actually changed into HTTPS. As you can see, we have HTTPS here. So now we even have an SSL certificate. Now, of course, the Let's Encrypt certificate is going to expire in 3 months. So what we want to do is we want to set up automatic renewal. And the easiest way to do that is just to sudo cron tab E, and let's pick nano here. And we're just going to set a cron job that will run, let's say, once a week. So minute 0, hour, let's say 4 a.m. And day of month is any day of month, and month is any month, and day of week is, let's say, 1. So I think that's Monday. 0 is Sunday and 1 is Monday. And we are going to run user bin certbot renew. And we are going to say user sbin, I think it is in sbin service, and Apache 2 reload. So we're going to renew the certificates and then we're going to reload Apache. And this will happen every week. And that's it. Now we have automatically renewing certificates. So the final thing I would like to do is I would like to change the user which runs the Gunicorn server, because now it's running as Ubuntu. So the safest way is to create a separate user for that. And that can be done by sudo add user, and we will add a system user so that it can't access it from SSH. And we want no create home. We don't want a home directory for this user. And we also want to create a group. And let's call this user and group Gunicorn. So let's create that. And then what we can do is we can modify our service and we can set it to run not as Ubuntu, but as Gunicorn. And group is Gunicorn. And let's save it. But now, of course, Ubuntu owns the srv/calorie app directory. So we have to do sudo chown r Gunicorn /srv/calorie app. So then it will be owned by the group and user Gunicorn. So now it should be able to access that directory and run it. So then, finally, let's sudo service. First we have to sudo systemctl daemon reload and sudo service calorie app restart. And let's see if it actually started. Let's check the status. And in fact, it is running. And if we go back here, it is still working. So now we should have a pretty secure Flask application running on our EC2 instance on AWS. So if you enjoyed this video or found it helpful, let me know in the comments and consider subscribing to my channel if you want to see more videos like this in the future. And let's end this video with a bonus, which will be to add some swap space to this instance. Because if we check our memory usage, we have just 454 megabytes of memory and 11 free, and we have no swap. So this server will crash very easily. So let's add at least a gig of swap in here. And how we do that is we can do sudo fallocate and L1G, and let's put it into /swap file. And then we have to do sudo chmod 0600 /swap file and sudo mkswap to make it a swap file, and sudo swap on swap file. So now if we check free m, then we actually have 1 gig of swap. But of course the swap space will disappear after we reboot, so we have to do sudo nano etc fs tab. And here we have to add /swap file, which is our swap file. And here we put none. And here we put here we put swap. It's very important to get this right, or otherwise your server won't start. And this is SW. And then over here we set 0, 0. I'm quite sure this is how you do it. So let's see if it restarts. Sudo reboot. And let's wait for a minute and see if we can still access our server. Okay, let's try to SSH back into it. And we were successful. And if we check free m, then we still have swap. And if we refresh this, we are still running our server and it works just fine. And let's actually check that this thing still works. So if we open a test image from here, then we should get a calorie count for this meal. And it still works. Amazing. So this is the end of the video. Thank you for watching and let me know your comments down below. See you next time.